Hey everyone, I'm going to talk about the Polygon method for adding vectors together. I would encourage you to look at the first page of the guided notes. So I have the solutions posted on Canvas. I'll click that, okay? So you can read through and get a feel for what a vector is. I'll briefly talk about that. So vectors are used to represent scenarios where you need a magnitude and a direction. A magnitude being maybe something like how fast something is moving, and then the direction being, what direction it's going in. So each of these vectors, for instance, we have vector A that's green, vector B that's red, and vector C that's purple. They all could represent a plane maybe that's traveling in a certain direction. So if you look at vector A, the plane would be going towards the east. Vector B, the plane would be going kind of towards the northeast, right? Vector C, the plane would be going north, which is kind of silly, right? Anyways, the longer the vector, that would mean the faster that the plane would be moving. So if vector A represented a plane, it would be traveling faster than vector C and vector B, right? Okay, one other thing real quick about vectors before we start talking about adding them together. It's, there's always a starting point and an ending point for each vector. The starting point, you'll see actually a point on it. This is called the initial point. And the end of the vector where you'll see an arrow, this is the terminal point. Okay, that's important for this method because when we add two vectors together, we actually want to take the initial point of one of the vectors and place it on the terminal point of the other vector to start off for this method. So what we're going to do, I'm going to try to draw vector A again down here. That one shouldn't be too hard. Alright, so that's vector A, right? I recreated vector A. Now if I want to add it to vector B, I want to try to recreate vector B. I want to make sure I don't change the direction or the size of the vector, but I want to place the initial point of vector B on the terminal point of vector A. So it's like if I could take this on a computer and like drag it and line it up down here. That's what we want to do. So I'm going to try to use my hands to make this as good as I can make it. So looks like it ends right about there. So you would put vector B like this. And now you have it set up so that you could add the vectors together. So if we add the vectors together, what color should we make this? Let's go with black. The resultant vector, it's called, will start at the terminal side of A, or I'm sorry, start at the initial point of A and end at the terminal point of B. So you just connect like this. That is supposed to be straight. And this is R, your resultant vector. So what we have here is that vector A plus vector B, make the plus sign red, I guess, is equal to our resultant vector R. And this is all just geometrical interpretation right now, right? All right, you can also add three vectors together the same way. And oh, I meant to mention, this is a polygon, right? I think that's why they call it the polygon method. You're always going to end up with some polygon at the end. Let's try to add all three of these vectors together. So I'm going to go ahead and copy down vector A. I'm just kind of estimating. So there's A. Let's go ahead and put B like we did before. Sort of estimating, so you get the idea. And then we'll connect vector C onto that. So let me recreate vector C. I'm going to put its initial point on the terminal point of B. Alright. Right about there. and so the resultant vector of adding these three vectors together is going to be the vector that starts at the initial, why do I keep messing that up? Starts at the initial point of A and ends at the terminal point of C. All right, so that's R. So A plus B plus C is equal to R here. And your textbook represents vectors with bold letters. A lot of textbooks represent vectors with a little arrow above them to say that it's a vector. And a lot of times in print, you put that there because you can't really tell that it's bold. So if you want to write your vectors like that, that's not a bad idea. All right, so I think that's pretty much it for this method. There's a question that I wanted you to ponder that's in the guided notes if you check those out, is would it matter if we switched the order that we added these in? You know, we attached B onto A and then C onto B. What if we switched it and we started with B and then put A on B, or would you get the same vector? And that's something interesting to try and see if it works. If you want the answer to that, check out those notes or look in your textbook. Adios.